look at this next example. So we have 2 plus x divided by x plus 2. So there's nothing really to factor here, but can we rewrite these expressions? Well, remember, addition is commutative. What does that mean? Well, it means that I can rewrite 2 plus x as x plus 2. If you're ever not sure about these properties, just use regular numbers. For example, you're probably pretty sure that 2 plus 3 is the same as 3 plus 2. They both equal 5. So you can prove to yourself, just using a general example with numbers, that that is true. So since that is true, I can rewrite this expression as 2 plus x divided by 2 plus x. Then, what happens when we divide them? Well, remember, there's always a hidden 1 out here, right? So this is really just 1 divided by 1, or just 1. However, we forgot an important step. The important step is that we still have some restrictions. What are our restrictions? Well, our restrictions are that x plus 2 cannot be equal to 0. And when we solve that, we find that x can't be equal to negative 2. So our answer is 1, comma, x can't be equal to negative 2. So if I were to graph this, it would look like a straight line. It would look like the line y equals 1, but there would be a tiny little hole in that line at x equals negative 2. Just like a tiny little hole in your sweater. It would be missing that value right there. All right, let's continue. So here we have 4 minus x squared, which is a binomial, and it is a difference of squares. So we can write it as 2 minus x times the quantity 2 plus x. And then in the denominator, we have a trinomial with a leading coefficient of 1. So we can rewrite it as x plus 2 times x plus 1. Okay? All right, so already you can probably see that there's some terms upstairs and downstairs that can be canceled. However, we always need to remember to do this step. Doesn't matter when you do it, it just matters that you somehow at some point list your restricted values before you cancel things out, right? So let's just do that over here. So we can say that x plus 2 times the quantity x plus 1 can't be equal to 0. So that means x plus 2 can't be equal to 0, and x plus 1 can't be equal to 0. Okay? So if we subtract 2 here, subtract 1 here. Okay, so we say that x can't be equal to negative 2 or negative 1. Okay, so we'll just kind of leave that sitting there. Okay, come back to our factored expression. Notice that 2 plus x and x plus 2, they're the same, right? Because addition is commutative, so those cancel out. So our final answer is 2 minus x divided by x plus 1, right, with the restrictions that x cannot be equal to negative 1 or negative 2. And that would be our final answer. Okay. All right, let's look at this one. We have x minus 3 and 3 minus x. So is subtraction commutative? So for example, if I have 2 minus 3, is that the same as 3 minus 2? Well, 2 minus 3 is negative 1. 3 minus 2 is positive 1. So they are not the same. But they do have a relationship, right? They're the same number with opposite signs, right? I could do the same thing if I did 6 minus 4. 6 minus 4 is 2. 4 minus 6 is negative 2. So the relationship between x minus 3 and 3 minus x is simply that we need to multiply by negative 1. So in other words, I could rewrite this as negative 1 times 3 minus x divided by 3 minus x. If you're skeptical and you don't believe me, let's just use the distributive property to prove to ourselves that this really is actually true. Remember, there's a 1 here, so negative 1 times 3 is negative 3. And negative 1 times negative x would give me a positive x. That gives me negative x plus 3, or x minus 3, which, lo and behold, is exactly what we have here. So, simply by switching the terms and putting a negative sign out front, I can, in fact, have a 3 minus x upstairs and downstairs. Now, you might be very tempted right now to go ahead and cancel those and just write the answer as negative 1. However, remember there's one extra step that we have to do. We have to remember that there are going to be restricted values. Specifically, we can't let 3 minus x equal 0. So let's just add x to both sides, and then we say that x can't be equal to 3. So our final answer is negative 1, comma, x not equal to 3. That is our final answer. Okay. All right, let's look at this next example. We have a trinomial, x squared minus 3x minus 10 in the numerator. So we can use the AC method, and we can also use the shortcut method. So we're going to have x minus 5 times x plus 2. Okay, and then notice in the denominator we have 5 minus x times 5 plus x because it is a binomial and it is a difference of squares. Okay. So let's look at this. Notice that we have x minus 5 and we have 5 minus x. Okay, so they're almost the same except for the fact that they're reversed. So remember, we can fix this problem, fix the fact that they're not exactly the same, by simply factoring out a negative 1 in either the numerator or the denominator. It doesn't matter. Okay, so I'm going to rewrite the denominator in this case as negative 1 times x minus 5, and then I have 5 plus x. Okay, and when I do that, it allows me to cancel out these terms. And remember, it doesn't matter where you park your negative sign, right? I could park it upstairs, downstairs, or outside. In this case, I'll just put it on the outside here. So I have negative x plus 2 over x plus 5. Or 5 plus x. It doesn't matter how you write it. It's up to you. Okay? However, remember, we're missing our restrictions. We haven't done those yet. Okay? So to find our restrictions, we have to go back to the original denominator, not the one that's already been canceled out. Okay, so we have 5 minus x times 5 plus x cannot be equal to 0. Okay? So I have 5 minus x can't be equal to 0, and I have 5 plus x can't be equal to 0. I'm going to add x to both of these sides, so x can't be equal to 5. I'm going to subtract 5 for both of these sides, and so x can't be equal to negative 5. Okay, so the excluded values I need to add over here are x cannot be equal to, we'll just say plus or minus 5, just to save us some room there. So let's look at some generalizations of these expressions. So in general, if I have x plus y over y plus x, I can rewrite this as x plus y over x plus y, and of course that becomes 1. Okay. Of course your restriction would be that y plus x is not equal to 0. You would still need your restrictions. Okay. If I have x minus y divided by y minus x, remember I can sort of rearrange this by rewriting the denominator as negative 1 times the quantity x minus y. Okay, and then these guys cancel out, and so this would be equal to negative 1, again with the caveat that y minus x is not equal to 0. Okay, x plus y divided by x minus y, there is no way to simplify this. Okay, there's nothing you can do. Remember, if you're like, I don't know, it feels like I should be able to do something, well, just throw some numbers in here, okay? So let's say I have, I don't know, 2 plus 1 divided by 2 minus 1. Well, 2 plus 1 is 3, 2 minus 1 is 1. Okay, if I had done what I wanted to maybe and, I don't know, crossed out like the 2's and then made this negative 1, right, that clearly doesn't work. That doesn't actually give me 3. Okay, so there is no way to reduce or simplify this expression. There's nothing more you can do. Just got to leave them alone. Okay, and same thing with this bottom one here. You could write it as x plus y divided by negative 1 times x minus y, right? But again, then you're back to x plus y divided by x minus y, and we already said there's nothing you can do here. Okay, so these first two are the only ones that can either simplify to positive 1 or negative 1.